The Australian curriculum is published by ACARA, the Australian Curriculum Assessment and Reporting Authority. Actually, that's a bit of a misnomer. ACARA says only a little about assessment and basically nothing about reporting. The federal government just doesn't have the resources or the money to manage any of that. Nevertheless, remarkably, the Australian curriculum is entirely published online. If you go to australiancurriculum.edu.au, you'll find all the syllabus documents there online. For me as a teacher, this is really good. The online copy is free and is always up to date. If I want a printed copy to do some planning, the website makes it possible to produce topic or year level summaries or comparison charts, but personally I usually just use it online. The Australian curriculum was born out of the Melbourne Declaration. A group of political and education stakeholders met together in Melbourne in 2008 and formulated a general description of what they wanted school education in Australia to look like. The Melbourne Declaration is very worth reading because it sets the scene for everything that's happening in education today. It talks, among other things, about students becoming successful, confident, creative, active and informed adults. Think about those words again in the context of mathematics. What does it mean to be mathematically successful, confident, creative in mathematics, active, informed? The syllabus documents themselves are shaped by general and subject-specific shape papers. The mathematics shape paper you should definitely read. Look at the kinds of things it says about mathematics education. Mathematics provides opportunities. It enriches students' lives. It has value, beauty and elegance. It gives students power to be sophisticated, to respond, to solve, to interrelate. Our students should become confident, creative users and communicators of mathematics. They investigate, represent and interpret the world around them using mathematics. They develop sophisticated understanding and fluency. They pose and solve problems. They reason logically. They recognise connections between different ideas in mathematics and between mathematics and other areas. And they appreciate mathematics as an accessible and enjoyable discipline to study. Think about your own experiences of mathematics education. What does it mean to be creative and active in mathematics? Notice the creative, active words in that list. Respond, solve, communicate, investigate. What about you? Do you appreciate mathematics as an accessible and enjoyable discipline to study? All of the Australian curriculum documents are built around several general cross-curriculum capabilities: literacy, numeracy, ICT, critical and creative thinking, ethical behaviour, personal and social competence, intercultural understanding. Obviously, in some subjects, different capabilities will be more relevant than others. In mathematics, for example, the emphasis is more on the first ones in this list: literacy, numeracy, ICT, and critical and creative thinking. However, the other objectives are still there. For example, in mathematics, ethical behaviour can easily be a part of studies in finance or statistics. Look for opportunities to embed all of the general capabilities in every subject area. Mathematics in particular is further divided up into 3 content strands and 4 proficiency strands. The content areas are number and algebra, measurement and geometry, and statistics and probability. In the old Queensland syllabus, statistics and probability was one of 5 content areas. In the Australian curriculum, the emphasis on statistics and probability has been raised significantly. This is considered an important area of understanding for people to engage successfully with the modern media-rich world. Let's look in more detail at the proficiency strands: understanding, fluency, problem-solving, and reasoning. Understanding is about students building a robust knowledge of adaptable and transferable mathematical concepts. They make connections between different mathematical and other ideas and develop new ones. They understand why and how the maths they use works. Fluency is about students using mathematics flexibly, accurately, efficiently, and appropriately. They need to recall facts and algorithms readily and use them regularly. They need to be able to manipulate mathematics to find solutions to problems. This is the kind of maths that's been traditionally emphasised and can be easily tested. How much of the mathematics you've just learnt can you recall and apply on a timed closed book exam? Problem solving. Students make informed choices. They interpret the world around them, formulating mathematical models to investigate. They interpret and communicate their solutions. They use mathematics to represent, design, and plan. They apply. They verify that their answers make sense and actually solve the problems they face. Reasoning. Students develop a sophisticated capacity for logical thought. They analyse, prove, evaluate. They explain, infer, justify, generalise. Students adapt and transfer their knowledge to new contexts. They compare and contrast. Notice once more the active and creative words here, especially outside the more traditional proficiency of fluency. Making connections, developing new ideas, formulating, investigating, communicating, analysing, proving, evaluating, generalising, adapting. How can we teach our students to do these things? What experiences can we provide for them to develop such skills? How can we assess how well they can do them? Because the best answer to that last question may not be with a written exam. Content-wise, the Australian curriculum mathematics is divided up into 3 strands: number and algebra, measurement and geometry, and statistics and probability. And then each of these is further divided up into substrands. Each substrand covers related concepts and ideas across a range of year levels. Some of the substrands develop from one to the next. For example, fractions and decimals in year 1 to 6 becomes real numbers in year 7 to 10. For the specific details about what concepts are in what year levels, have a look at the online document at australiancurriculum.edu.au. To give you an idea, here's the number substrands at year 7. Number and place value, real numbers, and money and financial mathematics.